This is lesson 2.1, radical expressions and rational exponents. So before we get into the lesson to change between radical expressions and exponents, we'll go over a few basic rules to know. So when the expression looks like this, where a to the power of negative m, we can change this by taking the reciprocal of it and setting it to 1 over a to the power of m. A similar rule can be applied where the denominator is a to the negative m. Like the previous example, we'll take the reciprocal and flip it, so we have a to the power of m over 1, which just is a to the power of m. The next example is when we have a to the power of b to the power of c. We can rewrite this as power to power, so we'll take a to the power of b times the power of c. In the next one, we can distribute, when we have a, b to the power of c, we can distribute the c to both terms and write a to the power of c times b to the power of c. So now that we have these rules, we can move on to simplify radicals. A radical expression looks like n root a, where n is the root or index of the radical. When we try to simplify these radicals, we can think about taking groups out of the inside of the radical and move it to the outside. So for the first example, we see that we have the square root of x to the power of 7. So we have 7 x's here. So we can write that out on the inside. So now we have 7 x's on the inside. And because we're taking the root, the square root, so we're looking for groups of 2, we can group out pairs. And these are just going to become individual x's on the outside. So we can rewrite this as x times x times x times the square root of x, because we have one remainder here, which is going to come, and we're going to leave it on the inside. And we can simplify this to x to the power of 3, because we have x times x times x multiplied by the square root of x. So for the second example, with a cube root, we have n to the power of 11, so we'll have 11 n's in here. So of our 11 n's, we'll look for groups of 3, as it's a cube root. This is one group of 3, another group of 3, and another group of 3. So now we have 2 remainders on the inside, and 3 groups of 3. So we have n times n times n times the cube root of n times n, because there's 2 left in the remainder. And we can rewrite this, because there's 3 n's on the outside, as n to the power of 3 multiplied by the cube root of n squared. So we're doing the fourth root of p to the power of 7. So we'll put 7 p's on the inside here. We'll take out one group of 4 that we'll write outside here as p. Then on the inside, we have 3 p's remaining, which can be written as p times the fourth root of p cubed. Now there's a faster way to simplify radicals when we know how to change radical expressions to rational exponents. We can use this rule here, that the n root of a to the power of m is equal to a to the power of m over n. So for our first example here, we have the square root of 5 x to the power of 6. So we know that the square root can also be written as 2 radical like this. And so we have 5 times x to the power of 6, when we have a single number, we know that there's an invisible 1 here, or the term raised to a single power. So with the n term from our formula here is 2, a is 5, and m is 1, just focusing on this part of the equation. So we can use this formula here and rewrite it. So we have a, 5 to the power of m, which is 1, over n, which is 2. Now we can focus on the x part of the expression and change some of these numbers and change some of these variables. So n still is 2. This time a is our x and m is 6. So we have x over m, 6 over 2, which we can then simplify to 5 to the power of 1/2 times x to the power of 3, because 6 over 2 will simplify to 3. The second example, we're going to apply the same formula to try and simplify. So we have the cube root of 12 to the power of 1 times z to the power of 11. So for this section of the expression, our a value equals 12 and our m value equals 1. So we're going to write a to the power of m, which is 1, over n. And n is going to stay 3 for the whole expression. And now we're going to focus on this part of the expression. And so our a and our m values are going to change. So a is now equal to z, and m equals 11. So a, z to the power of m, 11, over n, 3. That's our final answer. For our third example, we know that the nth root of a to the power of m can be written as a to the power of m over n. So when we apply this to this third example, we can rewrite this using our n and our m values. So looking at this expression, we know that the n value will equal 7. It's in this spot on the radicals. And our m equals 3. We see that here. Our a value is going to equal 4x. So now we can rewrite all of this as a to the power of m over n. So we have a, 4x to the power of m, which is 3, over n, which is 7. And we can use our rule that we previously learned, that ab to the power of c equals ac times bc. So we're going to distribute the exponent. So we're going to distribute the exponent between the 4 and the x. So then we can rewrite it as 4 to the power of 3 over 7 times x to the power of 3 over 7. So for our last example, we'll apply the rule n root of a to the power of m equals a to the power of m over n. Here we can set our values of a, m, and n. We know our a value is going to be 32, the m will be 3, and the n will be 5. Once we have these values, we can rewrite it in this form. So a, 32 to the power of m, 3, over n, 5. With a calculator, this can be simplified to 8. So in this example, we found a numerical value because we're not working with unknown variables. So using the same idea and formula that we just talked about, we'll do it in the reverse order. We'll change them from rational exponents to radical expressions. So the first one, our a value will equal 125, the m equals 4, and the n equals 3. We see that here, referencing this formula here. We're going to change a to the power of m over n to the n root of a to the power of m. So our n root, which is 3, to the power of a, 125, to the power of 3, to the power of 4. Now the power of 4 can be written out as 125 times 125 times 125 times 125. You'll see it happens you'll see we multiply it 4 times. 1, 2, 3, 4. To expand it out like this, we can use the grouping method that we used at the beginning. So we can take this group of 3 out, and we'll move it to the outside. So 125 times the cube root of 125. We have a single remainder which will stay on the inside. Now the cube root of 125 we can find by breaking this up into, you can break up 5 and 25, and we can do it again, 5 and 25. Now here we see that we've created a group of 3 5s. And because we're looking at cube roots, we can also move this group of 3 5s to the outside of the equation. So now we have 125 times 5, because we've moved it out, equals 625. So just to go over that again, we've taken this group of 3 125s outside, we've put it here. Now we're focused on this part of the expression. By creating a factor tree, we'll take out the greatest common factor. We'll take out the greatest factor of 125, 5 and 25, and we'll split 25, this number here, up again into its factors of 5 and 5. How we have a group of 3 5s here, we want groups of 3s because we're looking at a cube root. So now we have this group of 5, we can move it out here with this 125, which takes care of this part of the expression. So now we have 125 times 5 equals 625. For the second example, we can rewrite it using this formula up here. So we take our n, which is 8, so the 8th root of u to the power of 5, to factor out and leave on the outside. So this is its simplest form. For our third example, 64 to the power of 1/2, we'll rewrite as the square root of 64. Now the square root of 64 is 8. So that's our final answer. In our last example, we'll rewrite negative p squared to the power of 5 over 3 as the cube root of negative p to the power of 2 to the power of 5. A to the power of b times to the power of c, we can rewrite this as a to the power of b times c. So our a will equal negative p, the b will equal 2, and c equals 5. So for this section of the expression, we can rewrite it as negative p to the power of b, which is 2, times 5, which is c. 2 times 5 is 10, so our final is p to the power of 10. So when we simplify, we'll have the cube root of negative p to the power of 10. One rule about exponents is that if the a value is a negative, if it's less than 0, and it's being raised to a even power, the result will always be positive. So here, as we're raising negative p to the power of 10, 10 is an even number, we can rewrite this as the cube root of just p to the power of 10, because we know that the outcome will be positive no matter what. And using our grouping rule from before, for the cube root of 10 p's, we have 3 groups of 3, and we'll move those outside. P cubed times the cube root of p, because there's a singular p left here that will move down here. This is our final simplified answer.